All right. So I actually have a fairly long talk, and I think I have an hour and a half. Is that right? But I guess I'll try to have it so that you guys can ask questions for at least 10, 15 minutes or something like that. I want to make this like as interactive as possible, given that I know it's like a large crowd. Um, so you can feel free to stop me if you see something that's like interesting and just shout it out, hopefully. So this is a talk that I gather a few of my works together. This is not comprehensive, so hopefully it fits a sort of a theme. And so I basically talked to Catherine and got a little bit understanding of what you guys are kind of involved in and what you guys might be interested in. So I'll talk a little bit about those technologies, but not actually teach you those technology, like such as machine learning or computer vision. But I'll tell you kind of like how we use it and how we find joy in doing things involved with these new technologies, so that if you need to, you can go back and search for ways of employing these techniques. Okay, so this talk is called Stories Under the Influence. And I'm your storyteller. So today's plan, I'm going to tell you actually about stories. I'm calling this sort of a technology of stories talk. So the works that fall under this umbrella are kind of varied, but you're going to see at least some sort of common trend. And then I'll tell you about like making stories. The reason I'm not telling you about the technology part is because that's actually the easy part. If you know how to tell a story, you can actually do anything you want, really, basically, because that's kind of the communication medium of choice for humans. And so, paradoxically, the machine learning and computer vision, all that cool stuff, you can learn online anytime. You can take a data science class. You can learn it here as well. Um, but the question is just how do I employ that effectively? So after telling you about a little bit about stories, I'll tell you three particular, basically stories, three particular projects that, well, actually, it's probably six particular projects, but fitting under three different general themes. So one is something that I do a lot in my practice is working with machines and human communications, as Amy was talking about in the introduction. So working with human understanding of machines, and also how humans understand each other through machines. The second general area is using technology, and in this case, I'm using biometric data, actually human EEG data, electroencephalography data. I know that might be a crazy term for you, but basically brain waves. Using brain waves to actually control devices, and in this case, controlling a game. And then finally, using stories to actually tell basically how do you say, to empower people who are vulnerable in certain areas of the world. So I'll tell you basically about a project that I did with the refugees in Bangladesh. And so actually they're under a lot of trouble right now because they got exported, basically, right? They got pushed out of Myanmar because they're Muslim and Myanmar is Buddhist. But actually now that they're in Bangladesh, they actually have to find a way out. I want to tell you that right beforehand because that's the last thing up, and I might be running a little bit late on the time on that one. So that's really important, and that's kind of the branch of my work that focuses on social good and technology for actually doing good for people, um, which is really all this is all about. Okay, so first I want to tell you about telling stories. So stories really, I'm going to come from the angle that you might not expect usually, which is that stories tell us about the people who tell them. Okay, so what that means is actually if you hear a story, the context and the background of the story is telling you what this person is coming from. So I have an example here. Somebody's telling me about how in their youth, their dad threw them into the water in order to teach them how to swim, right? Now there's different interpretations, right? So one thing that this person could say is like, oh, because of this, I now learn to take risks because now I'm an entrepreneur. So basically they interpret that, they build that story up to be, oh, my dad throwing me into water was perfectly fine strategy for bringing me up to be a successful, risk-taking, person, right? Now a different person could actually spin it the other way. They start the story by saying, my dad threw me into the water. And then they say, well, actually, you know what? That's why you never trust authority figures. That's why you have to fight for your own rights, your own independent decision making. And in that case, you're really just saying that, okay, that didn't do a good thing, but despite that, I overcame that and still got to where I am, basically, right? So you notice that this sort of the same story is actually telling you differently about the person depending on how they're using it, really, right? So that's kind of one of the major things that I want to get at because when we're using art to tell stories, this happens a lot too. I mean, we're subjectively doing very different things when we tell stories in art. And actually, you will see in my work that I kind of purposely spin things a certain way, especially with the human machine interaction stuff. So just to re-emphasize that a little bit, um, so we edit stories for our purpose, right? So stories that we tell are told in a light that shines well on us. You know, it's kind of like the Instagram filter for your digital age of storytelling. So for example, this thing here, like actually what you're doing is like hanging out at a party, trying to be cool, dancing, right? But you could tell the story as like dancing with the stars, like, right? So I see this a lot because I do some social dancing as well. Like when you're doing the process of dancing, you feel like, oh man, I'm doing all this, you know, looking so good, and then you go and look at the video, and actually, you know, just like, you know, kind of humble, you know, nerdy kind of dancing, right? So we edit those stories for good though, right? Because it doesn't matter. We're having fun, and when we tell that story to other people, we tell the one that where we're looking really cool, right? So it kind of doesn't matter. But it's something we do for a purpose. Um, but on the other hand, the opposite thing also happens. Our stories also commit us to something that basically they influence us in a direction too. So what I said before is that we influence the stories we tell, right? Like so, depending on who we are, we tell the same story differently. But what I'm saying is actually when you tell the story the way you want it, that actually propels you to a certain extent. So, for example, like when you're a little kid, you could have told a story where, you know, because of a certain experience, it made me, you know, I saw a sick person or something like that, and I saw something on the news that made me really want to be a doctor. Now, that motivating factor, you may or may not initially, you know, later on, you might have been, you know, oh, technology is so cool, AI is so cool, I want to do math or something. But because you told that story early on in your life, that life contributes to you wanting to make that vision possible. So when you tell stories, and actually you can actually reflect back on your own personal storytelling, and you probably will see this sometimes, is that when you told a story about wanting to do something or being able to, you know, dream of a situation when you graduated from here with an amazing project or something, that thing kind of becomes true because you now kind of work towards that. That makes it part of your personality. So that's why I say like always dream big, even, you know, it's a dream, but it makes you a better, you know, it makes you, you know, it motivates you to do as much as you can, you know. Um, so right, so the stories are gonna influence us both ways, and I think in my work also I find that as well. That the stories I tell actually kind of fit it so that people, audiences are expecting to do something, you know, based on that. And you will see that in especially the artistic intelligence project. You see that. Okay, so I will keep this part a little bit brief because it's a little bit theoretical here. Um, um, but I wanted to give just a few little subtleties about telling stories. So when we're telling stories, it's actually a very I think of it. So I had to think about this a lot when I was doing this, but basically it's a complicated situation where it depends on the environment and the context that you're doing. I mean, I'm giving you some very difficult words here. You probably don't have to understand that. What this means is basically that when you're telling a story, it depends on the situation that you're in and depends on the mental attitude and, you know, in particular that you're doing. Not only that, but the semantics of the story will differ between people. So in this example, someone is like, call me a cab. And then the woman is like, okay, you're a cab. Right? Like, so the semantics of the way you tell the story actually matters beyond just having the meaning correct, right? they tend also to be very transdisciplinary. Like you've seen that term used a lot. So that the difference between that and interdisciplinary means that not only is it utilizing different disciplines, but it's actually participatory. So that's where the story part comes in. So when people say transdisciplinary research, they kind of mean like usually where you're actually taking some participatory action, like you actually go out there and do something about the thing that you're studying. That's what usually people say by transdisciplinary, and the story format kind of fits that really well because when you tell a story, you influence somebody to actually go out and do something. Um, it's also related to this, and this is kind of like recent research that I found this out, but so many of these things are falling into different areas, but they kind of put back together. But there's also this area called mixed research methods. And so there basically people use both qualitative and quantitative data. So when you think of research, a lot of times what you think of is like, tracking your eyes or, calculating ratings when you get a survey, something like that. That's very quantitative. But a lot of the ideal that comes out of the research that happened right now is that to understand that actually that quantitative level understanding doesn't get you to the depth of the information. So I kind of think of it as like even if we do a lot of scientific research to understand how a circuit in the brain works or a certain physical phenomenon occurs, there's actually another dimension that you can only understand by talking to people the right way, because everything is filtered through people's perception of how things occur. So like to think of that sort of part that's not quite accessible to science in very deep ways as story research. It's kind of like you tell stories not because you want to avoid the truth, not because you want to have a subjective story, but you want to tell a story because it is the actual truth that doesn't get uncovered when it's just numbers. So what I'm saying is the numbers are still limited, and actually there's the hidden agenda, the hidden value behind it that you uncover using stories. So that's kind of paradoxical because most of the time we think of stories as subjective, so therefore not scientific. And we think of science as the objective truth. Sorry, I'm going off the cuff here a little bit. But having done a lot of science and published a lot of papers in different journals, I actually think that actually it's happening in science too. So for example, when you're writing grants, fellowship applications, pitching your business to business partners or ventures, right? Actually, what you're doing is actually just telling a story, right? So think about it. Science is supposed to be objective, but actually, in order to do science, you have to get the money by telling stories. So what that really means is that even the science doesn't really, you know, there's a lot of truth that gets uncovered by science that's really important, and it tells you a lot about the physical nature of certain things. And psychology actually is able to study people in enough depth to really understand a lot of behavioral concerns. But I think there's still a lot of gray area that where things like arts and storytelling actually uncover for you. So that's kind of the main message that I'm putting forth here. And then in these projects, hopefully I'm getting you a sense of that, where it's kind of going beyond the science. Sorry, went kind of fast. Do you guys have any comments, suggestions, ideas? Agree or disagree? I would love to hear disagreements, by the way. That's how I learn. So, but we can also talk later on when we get to the Q&A. Okay, so this is the map that what we're going to talk about. So I like to call this sort of a hybrid practice. And actually, this kind of thing is I don't want to say trendy, but it's kind of coming, right? Like a lot of new media folks are doing practices like this. MIT Media Lab does a lot of stuff like this. The upper half of this is basically human-machine interaction. I'll tell you about some stories I told about how machines that behave sort of like human but not really like human interact with us, and I tell stories about how those happen. And then the lower half is using basically technologies and telling, basically both using technologies to understand us and also to understand certain vulnerable populations. Okay, so I'll go one at a time. Hopefully we have enough time. So the first project is called Lamp and Odyssey, right? So in this project, basically, if you look at this picture, right, probably certain things will conjure up in your mind, right? So does anybody want to sort of try to describe what you're seeing? You can just tell me what you think this is. Anybody? Okay, go ahead.
It looks like a metal lamp held together by like wooden base.
Do you think it's feeling a certain way or no? It's just sitting
I
there,
mean, it does look sad.
right? It looks sad. Yeah, yeah. Anybody else? Yeah, back there. Great, great. That's exactly what I was hoping for. So basically, so this is an object that I built. But what you notice is that machines, they already have extra machine properties without us having to do anything. Like you guys were describing, I didn't probe you to give a lot of information, but even just looking at the picture, you kind of say, okay, it looks like it might be sad because his head is kind of down. You reason that this is kind of like its head because it's a humanoid in some way, right? Um, so basically, in this project, I wanted to figure out how people perceive these things, and also to figure out gestures that I can use to tell stories about machines, and to see how people interpret those stories, right? So usually, what people have been using machine intelligence, like learning, neural networks and machine learning, to do, are to do human-based things, right? So there's a couple examples I'm giving. Uh, the one on the left is basically a machine that basically tries to mimic this artist's style. So it's actually the machine that's actually drawing on this paper, basically, and it uses neural networks to basically learn what the machine's previous work looked like. So therefore, what its future work should be kind of like. So this is what the kind of state-of-the-art folks are usually doing, like things like the Google Magenta project, for example, using data, using machine learning, neural networks type techniques to basically enhance human abilities or mimic human styles, right? Um, so what I'm saying actually is that actually maybe there's another thing that's not that. So the first thing I did is I built this chatbot, right? So this chatbot, you notice, it said something. So this it's actually a psychotherapist. So what happened is like so this is the chatbot's saying. So the chatbot saying, "Oh, please go on." Like so, and then the person is like, "Oh, I think I'm too fat," and looks like he's he or she is sort of suicidal, and then the chatbot just doesn't say anything, and then the person is like, uh, are you, what's going on? Like, I mean, how does that make you feel when you say something and then they don't reply, right? So chatbots don't work this way. If you go on Amazon or whatever bank app, they just reply to you, right? So what I found that when I just vary this duration of pausing, so this has no machine learning, right? But by varying that, people already assign machine learning like capabilities to it. Like it's saying, oh wait, like is it figure something? Is it what is it trying to figure out? Like is it talking to somebody else? Like why is it not being attentive to me, etc. Right? So that's why I found that actually a lot of this is you can actually do with basic gestures. So this points out to me that actually machine learning can just be simple gestures, right? Now I'm also going to do hardcore machine learning on this, but what I want to say is actually that's an important thing that you don't want to miss, basically. Because the reason it works is because human psychology, like humans perceive things a certain way. Then that's actually the ultimate engine that I use for my work, if you think about it. Because I'm saying that actually a lot of stuff, you don't have to build it into the machine. You let people do it. You let people do the work for you because people are great at making stories, basically. Okay, so I started with that, and then I decided to, well, let's see if we can do something, a physical manifestation of a gesture like that, right? So on the left here, you're gonna see basically a lamp that basically kind of shies away when person gets close, right? So actually this lamp also kind of tracks your face. So that actually uses basically offline machine learning. Um, I guess I'll show you on the video. I didn't have a GIF here, but basically the lamp actually tracks your face as you're moving as well. So that uses computer vision, which means that algorithm learned basically using machine learning what a face looks like, so that it knows whether it's an image of a face versus not a face, like a trash can. Yeah. So and then of course the one on the right, what is that? That's how did I get it to do that? I mean, I just programmed it to go like this, right? But when you see it in the storytelling format, you're gonna assign, you know, things to it. Okay, so without further ado, I'll just play the video. This is a real story.
Baiana que entra no samba, só fica parada. No samba não mexe, não come nem nada. Não sabe deixar a mocidade louca. Baiana é aquela que entra no samba de qualquer maneira. E mexe, remexe, dá nas cadeiras. Deixando a moçada com a boca louca.
So,
Baiana que entra no samba, só fica parada.
so when I've asked people qualitative research to ask them how they feel about things like, oh, so that's when the lamp, yeah, it's breaking. But what they feel like is actually the lamp is shy, but aggressively shy. So that's something that I learned from the user feedback, and then I tried to make another model that was less kind of super aggressive going that way. But what you find actually, the really interesting one is the one where the two girls are there and they were like, oh wait, now he's, the lamp is looking between each of us. And actually for that one, they end up like kind of competing for attention. That's really interesting too, right? So this is just an algorithm. I mean, this code is like kind of 1-2 pages actually. So basically for the sort of technical part of it, what I did is I basically just made the wooden frame, and it goes with the servo motors, and then I use this thing called Arduinos to control the servo motors. The important thing is that I connect the computer vision part, right, which follows the face, with the actual movement of the servos, right? So for example, when the person is on the right side of where the lamp is looking, right, where the camera is looking actually, then the computer, which is attached to it, will tell it to move this servo this way, right? So those are kind of the stuff that you could do to learn how to do in class, of course, by doing creative technology, but also learn a lot of stuff online, using like, do-it-yourself type methods as well. So okay, so that was one machine, and so by the way, in this picture, she kind of caught the part where before the lamp kind of turns. So it's actually I got a really interesting view where the person is actually looking directly at the lamp. So yeah. Anyways, so this is like one machine. So the question was like, can I extend this to groups of machines? So that's more of a complicated and difficult issue. And actually, I'm right now working at Cornell Tech with chairs, where like a whole room of chairs that can kind of map around and move as well. So that's kind of a further elaboration of this project, which is I'm calling the Secret Lives of Machines. So in this case, basically, they're sort of lamp-like in certain ways, but these individual minions are actually going to be tracking your face as well in certain ways. And they would all look at you in a certain way, but now I can actually do more interesting stuff, such as moving one of them in a different direction. And I can also do things like when it's seeing your face, it does one thing. When it doesn't see your face, it does something else. So the latter part of that is what led me to call this to the secret lives of machines. So this is someone looking at the project. So what you can see actually, just even from this view, is that they all a little bit different. There's one that has a light that kind of shines, or kind of like the lamp in different places. And the machine that she's directly looking at, it's very subtle, but there's a little kind of marking right here. That's because this guy actually has the camera on it. So the camera actually sits way back here, and the idea is that the camera back there is seeing where the person is and controlling each one of the, agents simultaneously. But this special guy right here he actually has a camera on himself, which means that if they can't see you through its camera, you can't get its attention. So what that means is that this lady right now is actually zooming in to look at that person's camera. So what I found that basically that gives you a different interaction, and it's actually, significantly different thing. So this is actually related to, I mean, this might be a little bit complicated for this audience, but it's related to this idea in AI where people are talking about, it's this field called reinforcement learning that basically tries to say, um, whether you're building a model for the world or you don't build a model for the world when you do the interaction. And in the latter case is the one that's mounted on the agent. If you're interested, just talk to me later. It's a very mathematical field. Okay, so the idea now is to understand how, you know, the way that machines see us can be used to conjure up some sort of collective interactivity. So in this case, you notice basically everybody's looking up here. So the person is like kind of up here on the screen. Um, and then to build a story, to tell a story how this interaction occurs, and I wanted to basically do kind of a fun thing, because I just like to play the little devil, is to see if you're not watching them, I just basically program them to do something else. So let's look at this video. It's also kind of a story, Romeo and Juliet like story, as you can probably tell from this title. So when you block the face, it's going to the other face, basically. That's what's going on. So they're playing a game where, so it takes a little bit of time for all the guys to get there, but yeah. So now they're not seeing any face, right? But then after a while, even that pattern of this looks enough like a face where they detected it. So now I'll use them to tell a story. So what happens if you're not looking? This is what happens when you're not looking. So I think one important thing that you might have noticed is that when I put labels of them, automatically you assume these folks are part of some story, right? So I think that's a really important thing is that basically human beings, by putting labels or putting language associated with certain objects, automatically make them real, right? And that's kind of part of related to the idea of that story forming our perception. Once you make a story, you're putting your mindset into that. If you dream of becoming, getting a JD law degree, kind of simmers in you a little bit. A couple of years later, you're gonna, you know what? I have nothing to do with my life right now. I'm gonna apply to law school, right? So that's kind of the kind of stories that I want to convey. So this is like me behind the back. So I'll tell you just a little bit of technology. You might be interested, but basically this is also computer vision. And in this case, there's a camera in the back. So basically, the camera in the back is detecting my face right now. And when it detects my face, instead of controlling those two motors in the lamp that was moving, right, I will now move all these guys at the same time. So this is it's called a Raspberry Pi. It's just it's a microcomputer basically that I use to control this. Now the subtlety here is that there's also one with the camera actually attached. So that one is actually controlling itself. And that one is more tricky because depending on where you are, it may or may not see you. If it doesn't see you, it'll just sit there. Okay, so those two projects kind of led me to a more of a culmination of this. So this was a exhibition at the New York Hall of Science. I did a designer in residency there. So I wanted to ask in this project, so I understand a little bit about how multiple machines could be interacting with people, and I did, the user studies to see what people are interested in. They play those interesting games. And so I also wanted to kind of use games as an interesting area to go. And this was also a museum. I don't know how many of you know of it. It's in Queens. It's actually a lot of kids go there as well. So we actually was tasked to make a workshop out of the exhibition as well. So what I decided to do here is actually I coupled where the camera is looking with a projection, right? So in this case, the projection will either show a face which is in the database of the algorithm, or it will show the face of the audience member. The reason I want to do this is to get more personal, right? Like so this machine to actually show what it could be seeing, right? Like so the idea to get inside the machine, so machine gaze, to understand what it is actually momentarily seeing. So this panel on the left here actually is the machine learning algorithm basically shown in a visual way so that people can understand, oh, okay, so I have to stand here and the lighting has to be good before it can pick me up. So it's an educational tool also for people to understand how computer vision in this case works. So this is the really cute camera that we refurbished. There's also a narrative that's associated with it because it's a story. So this is a surveillance camera from the 1960s. It's from a supermarket in the Bay Area. And basically what it was doing before was tracking shoplifters, in this, safe way. And it's kind of a very boring job for this little guy. And, we refurbished it. And what we did was just add in computer vision. So now you can actually detect faces and follow faces, right? What you're going to see is actually this guy is a little bit of a culmination of the previous two models combined, because this guy can actually both follow faces and just do its own thing, right? And you notice the camera is actually on this, right? So the camera is actually on this. So it looks like for actually making this is actually interesting, right? Because the actual camera is actually taken out and you put in a webcam basically to actually mimic that. It looks still like a surveillance camera, but actually it's changed so that we can actually program it using things like Arduinos. Okay, so this is kind of the diagram for how it happens. So in the exhibit, the main thing you might get out of this is the one on the right, where there's projectors coming down, and then there's a camera in the middle, and actually, right where the projectors intersect right here is actually where the face sculpture is. So when nothing is happening, it will just loop through sequences of faces, right? These faces are actually the ones that are basically used in the OpenCV or in the algorithm, basically in the camera, in the computer. So so again, so this projection actually goes onto the sculpture, and when it detects a face, it actually basically projects the face on there, right? So when it finds the face, so this is kind of a lot of complicated, what is called projection mapping. Also, really interesting field if you guys want to get into it. Um, but being able to project things three-dimensionally onto things such as this sculpture, um, and also to have that be interactive, right? That's a very interesting stuff that a lot of museums are going after now. Yeah, so I'll just show the brief video for that as well. Yeah, loves kids' faces. Yeah. Gravitates towards kids' faces. So yeah, so people love basically playing with these. This is how we installed it. It's actually right next to this thing called Connected World uh, at NISI. So it's a very popular exhibit, Connected World. So I was working with folks who are actually they call them explainers, but basically they're part-time folks at the museum. So it's actually really good to, actually one of them is a high schooler. It's pretty cool. So they contributed a lot to the project. So in the workshop that came after, we let people take on disguises. So the idea is you train the computer vision algorithm so that it's detecting your face, and then we just let people wear disguises until the algorithm can't see anymore. So it's a really fun way. So what then some of these people did is actually they took the disguises onto the exhibit, and they found that actually it still detects faces, right? So the workshop was also really informative for them. Okay, so that was sort of half of it. That's good. I think I can sort of slow down a little bit. Do you guys have any questions about the technology? I can explain, anything from the projection to the computer vision in more detail than I have here, if you're interested. Or just thoughts, recommendations. Yeah, Beck.
When, particularly, I guess, the lamp, when you decided to adjust how it interacts with the movie, did you have the technology to do that originally, but just decide not to implement it, or did you actually have to test it out and then realize what you needed to do in order to adjust? Does that make sense?
You mean you're talking about the computer vision, right?
Yes.
Yeah. So actually, I started with the design. So like the idea is, you sketch out an idea. So my idea was basically, so that's a really good question, by the way. So my idea was just to start with the object. In this case, the device, the lamp. And then I thought, okay, what does the lamp do, right? It lights places, right? So then I thought about, well, when people interact with it, like what are some of the things that they might not expect, but then they could automatically assign some human properties to it. So one thing is curiosity. So basically, I listed a few emotional, personalities, right? One of those was curiosity, and so the curiosity actually mapped to the tracking of the face actually. So it wasn't. I kind of wanted to work with computer vision, so it's not one way, street. Um, but um, but curiosity was definitely something. And then when people are far away, you can actually see the lamp, kind of like, oh, I wonder, you know. And then the other thing was the shyness. And so I found basically initially, obviously, I only implemented one thing, and then people were. I mean, you can imagine it's fun, but it's one thing. After a while, they're just like, oh, just track my face. And then, but when you add in the other thing, that's where like the richness comes out. When you add in the other, so the other thing that I did is there's this thing called the ultrasonic sensor. It looks like two eyes in front like that, but it's that's just what the sensor looks like, and when it just senses the distance to the person. And then when you have an object or person or anything that's close to it, it just basically triggers and in the computer, in the code, this distance is less than a certain amount, so I'm going to move the motors a certain direction. Right. So that's to hit the other personality trait, which is the shyness. So what I found basically with the testing, one after another and separately, is that if you have only one of them, people are amused, but they're not, they're just amused. But if you have both of them, then it's really interesting because it's a mixture of things that makes this lamp really personal to you, and you just have this feeling, and that's why when that lamp goes down sideways, people were like, genuinely, you can kind of feel a little bit. Like I showed that video, and people were like, "Oh man, the lamp is dying," So, great question. Anything else? Oh yeah. Please. Yeah, there's a lot of things. So like for example, right now I'm working on chairs, and then previously, basically, people worked on very famously mechanical ottomans. So what it look, it's like a kind of a table. So just imagine, I don't know how to describe ottoman. It's kind of like just a right. Yeah, kind of like a footrest. So people would move that around and then like stop and then move that around. And then in the study, basically, they look at people like they have all kinds of reactions to that. Some people are like, what's going on? I'm gonna take my feet up. I'm never gonna put it down. Other people figured it out. Like when the ottoman moved closer, they go, oh, okay, I'm gonna put my feet on. And then when the ottoman started to kind of do this shaking back and forth, they go like, oh, okay, they want me to take my feet off so it can move away. So it's actually a really interesting usability and whatever study. If you're interested, it's actually from the lab that I'm working on the chairs with right now. But yeah, at the time, yeah, there were many different things. I thought about doing a bed. That was really hard because you need humongous motors, and they didn't also quite have the gestures. Like different things that you do have different ability to evoke things. So the lamp actually worked really well. There was also a precedent called the Pinocchio lamp, which I forgot the university, but somebody built that was like super lifelike. But I mean, a lot of it also is kind of, um, some of it is fake to a certain degree, but they actually had a really nice engineering part of that. And so I wanted to kind of sort of study that and kind of implement some of the stuff there. But that one doesn't do the computer vision stuff. So that's just the Pinocchio map is more of a really cool technology, but now I wanted to add in the human interaction a little bit more, as opposed to kind of a choreographed thing that they did. Yeah, so maybe you are now inspired to do other objects, right? Like you can do anything. But one reason for chairs is they have locomotive properties. So now you can do any kind of interesting movement gestures as well. So, if you're interested, I can come and show you some of the videos we have of that. chairs moving around, remapping the space that we're in, etc. Do you have any suggestion, other types of things, tables? People did trash cans too, like automatic trash cans to, like you can imagine like people don't really throw away their trash. So the idea here was just like to move the recycling bin and the trash can strategically so that it forces people to more kind of use them in the right way and to not use them when it's not supposed to be used, for example. There was some research on that. Cool. So the next half of the talk, we're pretty reasonable on the timing, is to look at some projects that still invoke storytelling in certain ways, but also do it in the context of like technologies, right? So the first one is the one kind of most, I think, analytically sort of a little bit harder to understand. You have to kind of come from where I'm going. So so when I was looking at this current project called Artistic Intelligence, I was working with the lambs and trying to understand how things work with humans. But I realized basically one fundamental things that keep popping up over and over is that the machine learning stuff that's out there does really cool stuff, detects faces, detects your happiness level, blah blah blah. But I am actually able to do some of that without actually using the real kind of machine learning, algorithms, right? I'm using computer vision, but that's based on not on machine learning live, but kind of a model that's already learned. Um, but what I want to do actually is to do the following, which I didn't find anything other thing out there, is to actually kind of pose the question differently in such a way that the machine will look to the audience to be one way, but actually do something different. And what I'm positing is that that difference is what is triggering us to think that they're actually intelligent. Question back there. There's definitely work on that. Yeah, I mean I don't know right off the top of my head right now, but I do know that the stuff that's out there right now, I mean I wouldn't say they're ready, right? Like if they're ready, you're gonna see startups and doing that stuff. They're more kind of there's these big conferences if you guys are interested. The biggest one is called CHI, and that's where you actually get to learn about how these things happen. So like if you're interested in the topic, I encourage you to kind of like Google, something like robotic trash can, CHI, something like that, or HRI, that's the other big one. And then when you add in that extra term, it really helps you narrow it down the kind of academic level research. Because if you just put down robotic trash can, Google just returns all kinds of stuff. Some of it is like GIFs, right? Like so, yeah. So it's kind of you kind of have to know how to look for the I think that's kind of what the education is for. Like a lot of the stuff is already out there, but you still have to learn how to look for it. And people, when you're in class or whatever, they give you guidance to actually kind of pinpoint that specific thing. So, so you can try that. But there's definitely work on it. Yeah. Yeah, I would love it if you inspire to do that, and I can. Huh? All right, someone else. You want to use it? Yeah. Yeah, it would be. It would be. It does require a lot, right? So that trash can, it has to it definitely needs computer vision because it needs to track whether you have people or not. I think the hard part is the movement part. That's what I've been finding with all these projects. The tracking with the computer vision, machine learning, people kind of can do it, but the mechanical stuff, the robotic interaction stuff, and it's kind of like while I'm in the robotic lab right now, that's like hard. Like that's like the physics part is not easy. Um, yeah. Okay, so let me keep talking about this, and we can at the end circle back to your questions as well. Um, so I love humans. I also love machines. So this is also going to be a project about humans. Um, So what you're seeing here is actually one of the 3 sculptures I made for this project. Um, so one of the main things that I thought about this is that actually when we think about artificial creativity, so I started from that angle. Let's just be clear. So I started with the idea like what makes machines artificially, what makes them creative, right? So the definitions are out there right now are not really creative. Like, for example, Picasso app, things like in Google where like it basically textures your images a certain way. Those are all machine learning stuff, but they're not super duper creative. You can kind of see the human imprint on it. Humans inputted something and you kind of change the style or whatever, right? So this is kind of an example of that. So what that means is that the machine creativity that we've been working on is still really like a human constraint. You're basically working on art that humans are spend decades, well, in this case, centuries working on, and you're kind of, everything that the machine does is based on that, thousands of years of human history, right? So what I thought is actually what you really want to do to actually have true creativity is you just want to surprise people. Like the machine that looks like something actually does something else, right? So I started with the basis of just, I mean, I know this box is surprising, but I had nothing else better to put on there. But I started with the idea of like these are sculptures, but actually they don't do what we think sculptures do. Like sculptures should just sit in a museum, right? They don't move for one thing. So I just basically look for every stereotype of every major stereotype of the sculpture and kind of subvert it. And when I subvert it, I found that people really enjoy the experience and find interesting in experience. And now a lot of them actually found the machine to be creative in some sense, right? And creative in the sense that it's not expected, right? So that's kind of the thesis from this project. So the 3 devices, sculptures are the following. One is the anticipator. The anticipator basically just sits here, and then when where your fingers gets close to this finger, it kind of tracks your finger. So it's either going to move left or right, and it actually does a very simple machine learning algorithm, basically just keeping track of the previous history of where your arm is. And so when your arm is on the left, it moves to the left. When your arm is on the right, it moves to the right. You're going to see in the video pretty soon, right? And it learns to predict where your arm is. And over time, basically, it gets a little bit better over and over, so that it's kind of over 50% where your arm is. So that's one. So the kind of stereotype it's countering is that sculptures don't move, right? But this is a sculpture that actually moves. So you can actually see the motor that's down here. Okay, so that's the anticipator. Then you have the arguer. So this one is really interesting because I had to program a. How many of you have a Google Home? Nobody? Oh, some people have a Google Home. Great. So I had to basically, modify a Google Home, right? It comes with the original hardware, the Raspberry Pi that runs it. But basically, I changed the API so that it talks back differently. So usually when you say like, okay, Google, blah, 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 and it does something, right? So in this case, it actually starts by repeating what you say, but you realize actually the more you say, it actually is not, because I go in and change the script. So it goes along with the idea of the surprise and the story making part of it. So this is countering the stereotype that, well, sculptures like don't talk, right? So in this case, it's actually a talking sculpture. And then lastly, I have a sculpture that actually has computer vision embedded in it, right? So it actually basically is able to track which side you're looking at from, and actually the LED actually tracks it. And also just the LED itself, which is embedded inside the silicon, is actually a really interesting thing that people find because it looks like it's kind of talking in a certain way, in a visual way. So people usually assigned it to like, oh, I think it's talking, but it's not obviously actually talking, right? It's just an LED. I program it to do different things. Mostly random, but also kind of computer vision, so it's kind of a subtle interaction. You actually kind of have to try it, okay, in the exhibit. So here's the video. So that's where it try to predict where your hand is. And it's just using the same distance sensor actually. It's just like long or short distance. So initially it's not very good. And then it's hard to see this exactly, but it gets, better a little bit over time. So now so now this after training basically. Basically you have a lot of averages and it kind of gets better.
How are you doing, soldier? You're doing great.
You're doing great.
Okay, let's go driving with my sculpture.
Thank you, let's go driving with my superstar.
Wait, you are sculpture.
Yes, I am superstar.
I am superstar.
I am superstar.
You are sculpture.
I am superstar.
Sculpture, sculpture, sculpture.
Superstar, superstar, superstar.
So, by the way, this is one script. I'm not changing. This is actually what it says. So, it's not just replacing the word sculpture with superstar. It's a grammatically dependent change, so that actually it will do this interaction when you talk to it that way. This is also a really fun kind of making project in general. So you can actually see behind what it actually does. So when you open it, that's what it's doing. It's a LED that you're programming, again using microcontrollers, and then it actually can detect faces as well. So I think the idea of this project is to, start exploring. I mean, this is not a final say by any matter, any stretch of the imagination, but to kind of have an understanding of how we treat machines, basically. What do we find machines to be creative? How do we find machines to be interesting in different ways? When is it that they're showing human-like emotions or human-like traits? And I think for me, fundamentally, a lot of it is about our own interpretation. So we have to understand our own interpretation uh, before we can do a lot with the machine learning side of things. But as artists and creators, that's where I think it's really fun, because this field allows you to do things like this, right? Like putting stuff that don't necessarily belong into places that, just, are giving you interesting interaction. So here, when I put in that computer controlled LED, I'm actually able to get it to kind of speak in interesting ways based on interactivity. The interactivity being basically detecting where the person is using computer vision. Okay, so the next two projects, the first is about using neurotechnology. So I used to do neuroscience before this. I did, basically publish papers in neuroscience. So I also wanted to basically try to use neurotech to tell stories, right, about human interaction in this case. So this is work with Fifi Zhang at Parsons. Um, and what basically this started with is to have this two-way mirror that I'm setting up. So these two people are actually looking through a mirror. So it's kind of a bit of a game. And there's a light on one side and the light on the other side. So the light will either turn on one side or the other side or both. When the light is on the right here, right now, that means she is going to see her own image because of this mirror, right? And then she over here is also going to see the person on the right image. So what I'm saying is, on the mirror, both sides are reflecting the image of the person on the right now. So if it's not the case that the light on the left side turns on, then the opposite will be true. Both people will see the image of the person on the left side. Okay, so that's the setup, and why do we set up a situation like this? And it's because of this fundamental insight that I found. This is from psychology and from the neuroscience work, right? So this is actually where the science and the art are kind of inseparable from each other. So basically, there's some literature and also just some insight that I found. So usually, when people think of a communicative relationship, it's someone who's speaking and someone who's listening. Like for example, I'm talking right now and you're listening, right? So the usual thing that people usually saying is, "Oh, I'm providing you information." So I'm the giver and you're the taker in this relationship. Usually, that's the way people usually think of it, right? I'm giving you information and you're just paying attention. But what I am actually figuring out right now is actually a lot of it is actually sort of the opposite polarity. So I want to think about this process as the person who's listening is actually the one giving their attention. So in other words, the person who's listening is actually the giver. Because think about it, if somebody's talking to you and you're paying attention, you're transforming your mind a little bit. Like you're accepting that person's influence to make your world different. Like you will now think of the world in a different way because I'm talking about this, this speaker listening thing, right? So actually, I should be indebted to you because you're actually giving me attention. So when we say it in colloquial jargon, we say, "Oh, you're paying attention to me," but actually that means you're providing me something. You're giving me the chance to influence you in some way, right? So I wanted to think about information flow in this way. So when you think about it this way, you realize that actually people, when they want to see themselves, they actually kind of want other people to see them. So that's the idea that they want the attention of other people, basically. Do I have a slide on that? Okay. So what that means is, if you guys, you all probably grew up on Instagram and things like that, right? You want to take a selfie, whatever. You want to see yourself, right? And so what I'm saying in this project is actually most people want to see themselves because they want other people to pay attention to them as well. And they want to pay attention to themselves. So this is inspired by work by Moritz Wierman, where so he's coming from a little bit different angle in terms of the theoretical side. So he was like kind of looking at schizophrenia and people um, basically seeing themselves in the mirror. So, but this is actually indebted to him. So he basically set up the same mirror system, and where there's two people across, and they're either seeing the other person or they're seeing themselves. So this is a setup that we borrowed. And then, but what we did is now we add in the interactive element. So we basically said we want to first try to use speech to control the light. So the first thing we tried is, okay, if you're talking more, so this is going back to this idea, if you're talking more, you really just want other people to pay attention to yourself. So therefore, you're going to show the image of you. Okay, so what that means in this context is that whoever's talking will have the light on its side lit up. Okay, now there's another thing that I did. This might be a little bit complicated. I'll give you just a couple of seconds to digest it. The other thing I did is to so this is stuff I did is actually to hook people up onto the EEG device, right? So you can actually detect attention signals from the EEG device. Some of you might have heard of things. Yeah, I know it sounds crazy, but things like Muse, which is a headband that actually detects your attention signal. They're not perfect, but if you try it and you pay attention, that number that it gives you back will be, systematically higher. And when you kind of go like this, kind of relax, number will systematically get lower. So what I did with the same setup now is to actually use this EEG attention signal to control the light. So basically in that case is if you're paying attention more, you're going to see yourself in this mirror, and the other person will see you. So it becomes a game where you're trying to fight for attention. So the commodity in both cases is attention. I think that's the main thing I wanted to say in this project. It's not about information. It's not about me telling you stuff that I work on, cool. It's really about you actually paying attention to, of all the thousands of things, million things in the world that you could be paying attention to, you're actually paying attention to this lecture right now. And thanks to Amy too, and Catherine to make it happen, right? So attention is the commodity that we're fighting for. So in the EEG, the higher attention will turn on the light that you have, and then in the speech, whoever's talking, I'm saying so usually it's like whoever's listening, you turn on the light, right? But in this case, I'm actually saying whoever's talking is the one that's controlling because it's the one that wants the attention directed on herself. Okay, so hopefully that sounds somewhat understandable, but we can talk about it more in the future. So this is what it actually looks like. So I'm showing the EEG one in this case. So whoever's attention signal is higher, I'll show you the actual attention signal in the video, but whoever's attention signal is higher is actually having their light turn on. The other cool thing with this is the experiential part of it. You turn off all the lights in an exhibition-like format, and it's just really eerie. I can't really tell you. You have to watch the video and see and experience it yourself. But just imagine there's nothing, all black, and you're just seeing yourself, seeing the other person, seeing yourself. That switch itself is actually a really cool interactive experience. And then we try to get people to play games. Okay, here's the narrative story. So on the bottom is the actual raw attention signal. So if you get the peak that's higher, that means your attention is higher at that time. So you notice that basically uh, whichever has the higher peak currently actually has the light turned on. So that's where the control with the microcontrollers in the computer come in. You also notice it's not perfect, right? You're kind of seeing the other person, but there's a little bit of you. It turns out to be kind of interesting. So like right there, you can kind of see yourself and the other person separating right there. It's actually a really cool, installation, experience. So, but the takeaway from this, I think it's really interesting to use neurotechnology. So EEG stuff actually, um, I mean, it's very close to you now. It sounds like it's really far away, but actually it's super used in design areas as well, like at Parsons where I was trained. The thing that I'm using, so I'll tell you about the technology a little bit now, is this thing called MindWave Mobile, and they just use it. Mattel makes it to make games. And basically what it does is you put it on, and when you're paying attention, this little fan comes on and this little block comes out because of the fan blowing, and you can kind of like move this little block by using your mind, right? But now you can use it to do really interesting technology using coding and creating experiences. Okay, so I have a little bit of time remaining. So the last thing that I'll talk about is, oh, okay. Yeah, so let me just very briefly talk about this, and then we'll give you the kind of 5-10 minutes. So the very last thing that I'll talk about is an experience that I created with these two folks. Basically, it's about the Rohingya refugee experience, right? So basically, what's happening right now is that other NGOs and companies are going there making VR experiences so that you can understand what refugees are going through. But the problem is it's very static. It doesn't involve them. And as soon as you step into the camp, basically it's not a camp anymore. They know who you are. They know what you want to, show. So what we said was, well, let's not make it a truth, versus, fiction thing. Let's make it about this participatory process. Make it about we're telling a story, but we're upfront about it. We're just telling a story. We're not telling the objective truth. So, that's wasn't right. Okay, sorry. So let me just show you a little bit of the thing that we did here, and then if you have more questions, we can talk about it later. All this is documented on the web. So and also talk through this. But basically, we met a family there. We met with an NGO, and then we were able to interview them. But the main thing that we did is actually, in addition to just taking a documentary of these folks, we actually involved them by teaching them how to use a 360 camera, how to kind of move in space, and then using that, they were actually we were able to kind of stitch together a story. Yeah, I mean, it's amazing to actually go there and work with these folks because, yeah. And so in the VR part, basically we're saying, we're saying, let's be participatory. Let these folks actually take us around in the place. So this person's actually holding the camera. In the VR, you're actually obviously witnessing the whole thing. Very immersive. You actually get a feel for what the camp is like. And the story comes directly from them. So we're trying to empower them to actually tell the story. So, and then you can also do some really cinematic things that haven't been explored with VR much before. So, for example, following this boy as he's looking for the ball. Movement in VR, super interesting. In general, just an immersive experience that actually uses this dynamicism and also kind of empowerment to actually allow them to make the film together with us. All right, so these folks are amazing. They don't ask for money or anything. Like they just, and that's why when you see the VR document, so now you can go back to the UN VR experience, watch their documentaries, right? It will be sad and like, oh, these people. Why is that? Because they want you to donate to them. But what I'm saying is that's not really the truth. It's just a movie. It's just a Hollywood movie. And in fact, the music that they use is actually like they compose as Western music. We're using Rohingya music. All the footage is just like kind of a combination of them and us. But of course, we're not really going to sell out in theaters, right? So, okay, so that's pretty much it. Thank you very much. Thanks for Amy and Catherine. Ready to take some questions. Please, yeah. Oh, cool.
No, actually, it's important. I've complained about this already a lot, but I'm glad to hear from you.
By the way, like, yeah, that's a great question, and I'm really happy that you stepped out and like talked about this with us. And actually, like the fact that you actually are going through that project and everything is really amazing. By the way, we should also talk later because that's a project that's ongoing. We're getting funding. Well, we applied to some grant funding for different places like National Geographic and things like that. But the specific technical detail, um, why don't I send you an email or something? It's just because there's a lot. I mean, just to be brief, I mean, basically the VR space that I was talking about here, that is a lot of journalism folks are getting into that. Because think about it, like newspapers are dying. I mean, they probably already dead, but we're kicking up in the shin right now. But a lot of journalism departments are looking for immersive experiences because they're quick and easy to do, comparatively speaking, and they give you a sense of what's going on. But I think the ethical problems of that is actually really interesting. Like when people went in to make the VR film, they come out and they say, "Oh, this is exactly the way the camp is," because we're not there. Like we just put the camera there, but there's a lot of But what I found that's not really what's going on. Like people in this camp are super happy. Like when you see in the movie, they're happier than us actually. They get used to this place. So in the VR film, they portray in the other VR films, not by us, they portray it as a missing thing because from the Western angle there's something wrong with both the people and the place that they're in. And what I'm saying is actually there's nothing wrong with them. It's something wrong with us actually. Um, sorry, I went off tangent a little bit, but we can, for the technology part, we can definitely discuss, because there's funding, I love the idea that, using it for, I guess, education and things are like that's gonna be really big. And I think as long as I think the encouraging thing is as long as you're motivated to do it, there's gonna be a lot of opportunities out there. Yeah, and I can point you to some that we've been discussing as well, like Sundance does stuff. Um, yeah, NGOs. Yeah, we can talk about the technology. Yeah, great question. These questions are great. So for the therapeutic part, well, I guess I can't go online right now. But I do have an off. No, I have an offline version of my website. That's fine. It's not like everything, but so we actually have been exploring that. So it's actually a perfect segue because it's also a VR project. And again, that's something that we're working with Northeastern actually on kind of an entrepreneurial project. So let me just show you very quickly. So the therapeutic part that we started. So I actually did in when I did my neuroscience work is I did it in PTSD, so like traumatic stress, basically. So when I kind of switched over a little bit to the digital technology and new media, the first thing that I wanted to see whether I can help people with stress and anxiety. And actually, there's a lot you can do because it turns out that therapists and folks like that, what they do is they spend a lot of time just saying, okay, imagine you're in a auditorium, there's a lot of people and the lighting is dim and then Amy's sitting there, etc., to help people with the speech anxiety. That's what I'm saying. But why do that if you can just put people in VR? So it was a very straightforward extension. So this project, again, you can go online or I can point you to it. It's called Verbal, VRBAL. And so basically in this project, working with, this is, with the Adobe Design Award folks, but so working with a couple of people, one from SVA, other from NYU, basically prototyped a system that uses machine learning to tailor, well, the movie doesn't show up obviously, but to tailor basically an experience where they actually go through something like this, where on the upper right here, where they get an intro scene and then they kind of like have a meditative period, and after the meditative period, they go through a customized uh, in this case, a 360 video scene where they actually have to make a speech, introduce themselves. And then that level difficulty gets changed over time, updated by machine learning based on how well they're doing. But I feel like this is amazing. We presented this actually just last week at RTech in Portugal, and I think this is also a really uh, good way to go. And actually, for this kind of project, it's just human resource. We just don't have time to do all this stuff. So right now, I'm trying to get some students involved with Northeastern, but it's more like just human beings. And I think that's where you guys, if you're interested in a project, like talk to people. Like you'll be surprised. They really need help, and also you probably will get a lot out of it because you're going to learn the technology that works, and all the funding that comes from that will help you do your things. Like for example, for the Northeastern folks right now, we're applying to this Idea Lab, and then the funding that gets to them will just pay for their work, you know, and then and not only that, but then it will help them if they choose to go get another job, in the industry. They have a really big portfolio item that they can use and things like that. So I would say just definitely get involved. I guess Amy knows more about the employment opportunities here, but yeah, but research though is a lot. Yeah, and research actually, you might not think that they pay a lot, but actually it's a very kind of a stable thing because it's like people have grants and people need people to do stuff. And look, you're not gonna make as much money initially, but your life will be more satisfying. So, and you might end up making more money in the long term because whatever you create from that will turn into other things. That's a great technical question. I'm glad you're looking into it. You're super like advanced. So my recommendation: do not use the Muse. Use the MindWave Mobile. The reason is the Muse doesn't. The Muse gives you the delta, alpha, whatever signal, right? You have to use that to calculate your own measure of attention or relaxation. That's what you're going to use. You're not going to use alpha value. Like alpha value has no actual human meaning. It's just some reading, some frequency spectrum. So now Muse could change that in the future. I don't know. The API might change. For now, you could either do something like MindWave Mobile, which has its own proprietary attention signal, which is calculated based on alpha beta. I mean, exactly. It's pretty easy to use too. So the idea is basically that like you can go and search the literature and calculate your own attention signal based on the raw data in Muse. You could do that. Yeah. Yeah. So imagine like the people in MindWave, they already did this for you, right? Like it wouldn't be good if they didn't do this. Like so the fact that it at least works reasonably means they basically went and did that. Now, the other suggestion I can give is instead of using a single electro, you could do other stuff, right? Do you know about OpenBCI? Yeah, so look into OpenBCI. They're actually in Brooklyn. So they're, you tell them you're a student, maybe they give you something for free. I don't know. Or just lend you something. I don't know. But so with that, you get a whole headset that you can, measure more information from. Now, we thought about that too, but actually the headset is also more invasive. So it's a trade-off. If you want a single electrode that does what you want, in the art context, but I'm happy you're using it. Hopefully, let me know what cool stuff you end up building with it. Yeah, sure. I actually built for this conference called Dynacon. I built this music thing too. Music, so like based on the attention signal, it just does a pitch differently. And then I superimpose it on top of a forest, like leaf forest electronic data. And then so that's controlling the background, and then the foreground is controlling the pitch using your attention signal. it sounds really weird. It goes like that, right? But you kind of like after a while you feel like you're in the forest. It's Halloween. It's kind of like it's kind of cool. More questions? Yeah. Yeah, that's a good question. So with that project, I think that was actually that guy, that the eyes closed person, is actually the linchpin of that project, right? Because it's the one that kind of brings together computer vision and like interactivity the most, I think. But for the specific question of the eyes closed, you actually was a technical constraint. So the way to make this thing, you have to go on the website to check out the process photos. But basically, you have to paint a layer of silicon onto people's faces to get the mold. So I wanted to use a real person. So it's probably hard to see that, but that face is actually her face. So she's actually looking at her own face, like her own mold. It wasn't super, easy to understand that, but if you look closely, like so, this is her, and then this is the face. You kind of see that a little bit, but you can't obviously cannot have an open eye thing, right? So to do that, it was just difficult because you would have to carve your own. You have to carve on top of the of these of the silicon to get the eye to be nice, and it's just difficult. So I just kept it closed. But yeah, it would actually I think would be served more if it was open because it's kind of like looking at you. In this case, it's kind of saying like I'm not really talking with my eyes. I'm talking with my mouth a little bit. I mean that's kind of a post justification, but you know, great question though. You interested in sculpture? Ava? Thank you. Yeah, so I mean, I guess one thing is like I'm not an expert on any of these, but I think one thing you might want to just kind of do is learn to be an expert whenever you need to, right? Like so, I mean, I just literally just took the sculpture class, and then obviously other people are doing other interesting artistic stuff, but I said, okay, I want to put technology into these guys, and then if you just have motivation to just say to do that, eventually you find a way to do some interesting stuff that crosses boundaries. So encourage people to keep.
I would emphasize that as a kind of closing point. Taking intellectual initiative is the key, really, for all of this creative work, and so much of what you do in digital design is about.
Yeah, and thank you for listening to that message, right? Because now that message is in you, and I'm like relieved, and then it goes back to the paying attention part. Like I'm super happy that you guys are here and kind of engaged in this stuff. And thanks to Amy and
Thank you
Catherine.
so much for coming.
Thank you.